Hi class, today we're going to go over solving multi-step equations, specifically ones that have variables on both sides of the equation. Before we get started, go grab your EL Algebra packet and turn to page 65. So on number 1, we want to write the equation based on our picture and then show our work. So I'm going to look at how many x's there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to write 11x and then minus 1. And then on the other side of the equal sign, I have 1x, but I can also just write x and then plus 99. Then I'm going to ask myself a question that we see on the right side here. What must be done to get from one step to the next? What side of the equation do you have more x's on? The left or the right? The left side has 11 x's and the right side only has 1 x. So the left side has more x's. So if there are more x's on the left side, then first I'm going to move all the x's to the left side. So that means if I have any x's on the right side, I want to move it to the other side by getting rid of it. So I have x plus 9. This is a positive x. So I'm going to subtract by x from both sides of the equation. Minus x on the right and minus x on the left. So that I have 10x. I'm going to bring down the minus 1. X minus x is 0. And then I bring down the positive 9. What I notice that I have here now is x is multiplied by 10 and subtracted by 1. So next I'm going to add by 1 on both sides of the equation. Plus 1 on the left, plus 1 on the right. Negative and positive 1 turn into 0, so they go away. And then I have 10x left here. 9 plus 1 is equal to 10. The last thing I now notice is happening to x is it's being multiplied by 10. The opposite or the inverse of multiply by 10 is divide by 10 on both sides of the equation. So divide 10 on the left and the right, and we have x is equal to 1. Or the solution is 1. Now, before we establish what the solution is, let's do our check. So that means I'm going to rewrite my equation, but instead of x, I'm going to write 1. So I'm going to write 11 times x, but we don't have x. We have 1 minus 1 equals x plus 9, but we don't have x. We have 1 and then plus 9. From here, we're just going to follow order of operations to simplify. We have multiplication, subtraction, and addition. I want to do multiplication first. 11 times 1 is 11. 11 minus 1 is 10. 1 plus 9 is also 10. So this means 10 equals 10 is true, which means the solution is x equals 1, and it works. All right, we're going to look at another problem. Let's look at number 2 down here. Again, we're going to write the equation based on the picture and show the steps. So I have 2 x's here. So I'm going to write 2x plus 3. And then I have 1x here plus 7. What side of the equation do you have more x's on? So when I look at my equation, there are 2 x's on the left side. So again, I'm going to move all my x's to the left. So to do that, I need to get rid of this x. This is a positive x, so I'm going to subtract x from both sides of the equation. This is going to turn into 0, so all I have left on the right is 7. And on the left, 2x minus x, or 2x minus 1x, is only going to give me 1x. And I'm going to bring down the 3. Next, I see x is added by 3. The inverse of add by 3 is to subtract by 3 to both sides. So subtract 3 on the left and subtract 3 on the right. Positive 3 and negative 3 turn into 0. And then I have x left. 7 minus 3 is 4. So my solution is 4. Now I need to check my solution to make sure that it's right. So I'm going to copy down my equation from above, but instead of x, I'm just going to write some parentheses so I can fill it in with what I got for my solution. The solution that I got was 4. And then again, I'm going to follow GEMS, or order of operations. There's no grouping, there is no exponent, but there is multiplication. So I have 2 times 4, which is 8. And then I have addition. 8 plus 3 is 11. 4 plus 7 is also 11. 11 equals 11 is true. So the solution is x equals 4, because when I substituted it in, it gave us a true statement. Let's look at number 3 on the next page. We're going to write our equation. So there are 3x's plus 4 plus another 3x's equals 8 minus 4. So this one's a little different than the previous one because on one side of the equation, on each side of the equation, I notice there are like terms. On the left side, 3x and 3x are like terms. And then on the right side, 8 and negative 4 are also like terms. So the first thing we're going to do is combine like terms. So first I combine like terms on each side. On the left side, we can combine 3x and 3x to make 3x plus 3x is equal to 6x. So I'm going to write 6x here and that plus 4. I can also combine 8 and negative 4. So this is on the right side. I can combine 8 and negative 4 to make 4. Next, I notice that x is still multiplied by 6 and added 4. The inverse of adding 4 is subtract 4. So next, I subtract 4 on both sides. So minus 4 on the left and minus 4 on the right side. I have positive 4 and negative 4 here, so they turn into 0, but I don't need to write it here. But on the other side, I also have 4 and negative 4. So since there is nothing else here, I do need to write 0. There is one more thing happening to x here. It is being multiplied by 6. The inverse of multiply by 6 is to divide by 6. So then I divide both sides by 6. Divide by 6, divide by 6, and x is equal to 0 divided by 6 is 0. So we're going to check our solution now just to make sure that it is correct. So I'm going to copy down my problem from above, but I'm going to leave parentheses for my 0. So 3x plus 4 plus 3 times x equals 8 minus 4. And we know from the work that x is possibly 0. We're going to simplify by following order of operations, following GEMS. There is no grouping, there are no exponents, but there is multiplication. 3 times 0 is 0. 3 times 0 is also 0. And then we have subtraction and addition. 0 plus 4 plus 0 is 4. 8 minus 4 is also 4. 4 equals 4 is true, so the solution is x equals 0. All right, we're going to do one more problem, number 4 down here. So to write our equation, it looks like we have 3x's plus 2x plus x equals 4x and then plus 12x. So similar to the one that we had up above, we have like terms on one side of the equation, or on one side actually. On the left side, we have 4x, 2x, and x, and they're all variable terms. On the right side, we have 4x and 12, but they're not like terms, so we can't simplify that side. But we can combine like terms on the left. So first, I combine like terms on each side of the equation. I can combine 3x, 2x, and x. 3 plus 2 plus 1 is 6. So I can combine those to make 6x. And then the other side stays the same. So on the left side, I have 6x, and on the right, I have 4x. I'm going to move all the x's to the left side because there are more x's there. So I'm going to get rid of the x that's on the right, the 4x. This is a positive 4x, so I'm going to subtract. I subtract 4x from both sides of the equation. 4x minus 4x goes away here, and all I have left here is 12. But on the left side, 6 minus 4 is 2, so I have 2 x's left. Now I have 2 times x. The inverse of multiply by 2 is divide. So next, I divide by 2 to both sides of the equation. Divide by 2, divide by 2, and x is equal to 6. The next thing we're going to do now is check our solution. So I'm going to write 3 times x, but 3 times 6, plus 2 times x, or 2 times 6, plus x, but plus 6, equals 4x, 4 times 6, plus 12. And following order of operations again, no grouping, no exponents, but there is a multiplication. 3 times 6 is 18. 2 times 6 is 12. 4 times 6 is 24. And then it looks like we have addition. 18 plus 12 is 30, plus 6 is 36. 24 plus 12 is also 36, and this is true. 36 is equal to 36. Therefore, the solution is x equals 6.